Good morning and good afternoon to folks. I see people are signing in, so we'll just give people a couple minutes to get logged in, and then we'll get started today. Hi, everybody. Good morning, good afternoon, wherever you are. Glad to see so many people are able to join us for the November webinar in the Division 34 webinar series this year. It's been really great to see people logging on and calling in throughout this very strange, unusual year. And I'm glad so many of you could make it today to be here with our speaker, Dr. Cameron Brick, who's an assistant professor in the Department of Psychology at the University of Amsterdam. Cameron does a lot of work cutting across multiple fields, including but not limited to environmental conservation psychology. I think it's accurate to describe him as a critical new voice in our field, and I think he's got a lot to share with us, and really has some really important insights that can help us improve the state of our field. And so I'm really glad that he was willing to join us today. I'm going to just have Cameron say hi quickly, and then what we're going to do is actually he has pre-recorded his talk, but he's here with us in person as well. So this is something a little bit different for us format-wise. One big advantage of this format is that as his talk is playing, Cameron is fully available to interact with folks via the Q&A through typing, and he can really pay attention to you, of course, because another earlier version of him will be speaking to us. And then he's agreed to stick around for the last 10 minutes or so. We'll have time for an open live Q&A as well. But folks should feel free to put questions in the Q&A box, and Cameron will be able to respond to them as we go along. Cameron, do you just want to say a quick hello to folks?
Yes, hello everyone. Thank you for coming. I've become more interested in methods lately. Hopefully some of these questions are interesting and useful to the broader environment and conservation population. And let's see, let's pose that as an open question, and I look forward to hearing your input.
Great. Let's go ahead and get started. And if anyone's having trouble with the audio, please do let me know right away, but we should be okay.
Okay, let's get into the talk. These slides are free use, so you're welcome to download them at that link and use anything that you'd like. It's a powerful time to be doing environmental psychology, and I wanted to include these 3 article titles, not just because people are writing about the climate crisis, we know that from our field, but that these are people in other fields. We have in the upper left ecology, in the middle cognitive science, and at the bottom neuroscientists. These are not groups that were involved in climate change, at least very publicly, when I started being involved myself. And so this is a very powerful time. The physical science is clear, and across the social sciences, people are getting involved. There's a nice momentum. And this momentum extends to the non-scientists as well. So in 2019, I was living in the UK, and the Extinction Rebellion protests were bringing people out to the streets that were not experienced at protesting. They were there for the first time, and they were brought out by the common message that something needed to happen around climate change, and that something needed to change in the government. And I put up the numbers of arrests here because usually at protests, the people who agree to be arrested is fairly small. And I say agree to be arrested because what typically happens, these protests are peaceful, nonviolent, and not that intense. They feel kind of like community events where people are just getting together. But the police may come along at some point and say, well, you're blocking the road and please leave. And if you refuse to leave, then they'll say, you do know that we might arrest you if you keep standing here, please leave. And if you say, yes, please arrest me, then they arrest you. This is a high bar. And so the fact that thousands of people were willing to be arrested really showcases the broad public involvement in the climate crisis. And so that's the framework for talking about why it's so important for us that we use the best possible methods right now and produce the most useful work to the rest of society. Me personally, my motivation for learning more about the methods I'm going to talk about today came a lot from supervising student projects. I'm going to say more about that in a moment. And from my own training, which was that the typical training when I went through as a bachelor's student and PhD student is now recognized to produce a lot of false positives. Broadly speaking, we were trained to p-hack. That's not because of any moral failure in the previous generation, just that it has now become super obvious that the standard scientific process as it was practiced for a long time leads to some really misleading conclusions. So what do we do now? Well, there's two groups that I do want to signal in particular that have been very helpful to me and also welcoming. And that's the Society for the Improvement of Psychological Science and the Psychological Science Accelerator. And I'll say more about the accelerator at the end of the talk. So this is the scientific process, broadly speaking. And you can see that it goes from generating hypotheses up here in the right, all the way around to maybe conducting another experiment and then generating new hypotheses. But in red here, we have problems that can enter into the process. And one of the key problems here is hypothesizing after the results are known. If you go back and rewrite your intro to be more closely aligned with what you found, that can create a problem about what the inferential tests were doing and how to interpret their results. In the design stage, we're often plagued by low power, which you can get around by planning what the power is before you run the study, rather than trying to figure out afterwards whether it was sufficiently powered. When the study is run and the data is collected, they're often not documented well enough. And I want to stress the main motivation to document your work properly is for you personally. Like I went back just recently and tried to write up some studies that were from 2014 that I ran them completely. I had every file that I saved. I had every line of code that I wrote. And there were some questions about that data I could not resolve because I hadn't written down enough information to figure out what had happened. Or in the code, maybe I had cleaned up the code, so I have this final variable that is a composite, but I don't have the individual things that went into the composite. And so it really is primarily for you, but it also helps other people and other researchers to use your work. At the analysis stage, p-hacking is where we manipulate the process to increase the likelihood of getting a significant result or non-significant, depending on what you were looking for. And the solution to that is also settling what you're going to do in the analytic methods before you do them. In interpreting the results, we have the same issue, which is sometimes called harking. It's an acronym for that sentence. And then at the publication stage, we have bias, so that only certain kinds of studies seem to get published, like the ones that find significant results. Now, there's a solution to all of these. I'll tell you about it in a minute. But there are also solutions to a couple of them in piecemeal, and so I'll start there. I mentioned that one of my motivations for improving methods came from supervising students. What I was hearing from the students who were writing bachelor's theses with me is that they were really frustrated that the largest samples they could reasonably collect, you know, convenient samples of 100 or maybe 200 people, that they just couldn't conclude very much from those samples. They aren't even large enough to stably observe correlations. That looks to be about 250, but definitely aren't enough for complex designs. They felt pressure to find significant results, but they didn't have enough N in their studies to do so. And it makes sense that we ask students to collect data to see a project through from design all the way to analysis. I do think that's valuable, but it comes at a cost. The cost is not necessarily doing any of those steps very well. And so I think my philosophy about the education of the research process is that sometimes we should be providing students with high quality data up front or showing them where to find it so that they can exercise really high quality research procedures on a smaller part of the process. That's for students, but also for researchers, me and my colleagues. I realize we often don't know what data exists or how to find it. And so because of that, I developed a resource I'll show you in just a second. This is just a comic, a joke. It's actually originally about climate change, but I modified this one to be about p-hacking. I'll let you read it. Yeah, I like it anyway. Okay. So what's our tasty medicine? I'll show you in just a second an open list of free data, high quality data. Then I'll talk about pre-registration and registered reports as a way to get around the research issues we've talked about, the Psychological Science Accelerator, and then I'll talk a little bit about how this has played out in environmental psychology specifically. Okay, here's the list of free data that I have compiled with some colleagues and the link there at the top. And what this is about 150 data sets listed that are totally free that you can download and use. Some of them require registering, but they're all free. And what the work to do this is to gather them together, but also to include some of this metadata. So you can see that scrolling through the document, you can see what is in the data set. That sounds trivial, but it's actually not a resource that existed before. There are lists of data sets, but they're generally using the kind of search function, like you'd have to write attitudes and then it'll give you a list of data sets that you could consider. But this very bare bones, very shallow interface is actually pretty easy for getting a sense of whether your data might be out there. And this received an award from the, a commendation from the Society for the Improvement of Psychological Science last year, which I was very proud of. Okay, so what could you use such a resource for? It has teaching applications in the classroom, like you can make assignments where there's already high quality data that you have selected in advance that's relevant to the themes of the class. Of course, it's useful in more stats applied classes because you can find data that's shaped appropriately for some particular model or question you want to teach. Another use that I've seen that I really think is cool is competitive p-hacking, where you give students the same data set. Let's say you divide the class into two. In one set, you say, please try and find this result any way you can. And the other side, you give the opposite. Please demonstrate this result doesn't exist or something. And they can create composites and they can use different kinds of tests and get creative. And it is a great way for them to see how, see firsthand what it looks like when you're p-hacking in a safe classroom situation where there's no advisor looking after them or anything like that. I also have used this list for project and thesis supervision on my active research. So last year, 7 master's and bachelor's level thesis projects using existing data, and everyone was happy. The program was happy. The students were very happy. And you can imagine why. The students are happy because they can ask a scientific question of interest to them and then get inferences from the data that are adequately powered. It's the highest quality kind of work. And it's appropriate for both exploratory and confirmatory work. We often don't do exploratory work because the data is so expensive, because we are in a rush. But one of the benefits of someone else having collected the data, and sometimes a necessity because they've asked the question slightly differently than we would, is that you really can dig around and play and do exploratory work. And sometimes when the data sets are very big, one thing you can do is divide the data set in half randomly. Do exploratory work on one side and then confirm your hypotheses on the other side. And that can be a nice way to bridge both of the needs of exploratory and confirmatory. So the resource I just showed you of the data sets, it's not complete. Not all the metadata is filled in. If you have research assistants or students, or you personally would be willing to spend 30 minutes entering data, I would be very grateful. So please, you can edit that directly. There's no permissions needed to edit the Google Doc, or you can contact me. Grateful for any help. Thank you. So Chris Chambers has been a real mentor to me in learning more about research methods. And here's a couple of slides that have been adapted from one of his talks. He often asks his audiences, what part of a research study do you believe should be beyond your control as a scientist? I think a reasonable answer is the results. And then he asks, what part of a research study do you believe is the most important for publishing in top journals and advancing your career? People also say the results, but this implies there is a profound problem in the way we're conducting science. And the solution is registered reports. So how do they work? At stage 1, authors submit a manuscript with introduction, proposed methods, analyses, and pilot data. And then that goes to peer review. Now, this doesn't have any data in it yet. You've just proposed what you're going to do. And the proposal is very well written. So the stage 1 manuscript has a fully written introduction that justifies why the work is being done and how it is positioned with previous work. And it has a method section, which has a very detailed analytic method that explains what tests are going to be run. And it demonstrates that the project has sufficient power for the key tests. You know, yeah, this is a lot of work up front before you submit. But there are benefits I'll show you in just a second. Then the stage 1 peer review is conducted, and the reviewers get back. Maybe you do a back and forward. If eventually the reviewers are positive, then the journal offers an in-principle acceptance. Oh, there's a typo there, sorry. Regardless of the study outcome. So the journal says, great, this is well built. We accept your project. Please run it. Then you go off and run it. And then you complete a stage 2 manuscript. The introduction does not change, or not much. You write the results as you said you would. You write the discussion, and then you deposit the data and materials in the public archive. It's a nice writing process at this stage because you know that the paper is accepted, and you're just filling in the values that you yielded out of the study. You don't have to oversell them. You don't feel any pressure to rewrite the story to match, you know, the new thing that you see in the data. You write it exactly as it is. At stage 2, the reviewers just look to see that the procedure was followed and that the interpretation matches the data, which is a much lighter review than most people feel generally when they submit a paper. And then your manuscript is published. Notice that in this process, it doesn't matter whether your hypotheses were correct, because the reviewers at stage 1 already saw, okay, this work is worth doing, whether or not they're going to find the answer this way or that way. It doesn't matter whether your results are significant. It doesn't matter whether the results are novel in that sense, like it could be a replication. And it doesn't matter whether the results have impact, whatever that means. It's more, are these methods high quality, and is the question worth asking? So do you personally have experience with registered reports? Have you reviewed one? Have you edited? Have you written one? The reason I started doing this was because I began to realize that methods were the one part of the project that I could control. And so I wanted to have more attention on the methods and to be given credit for it. One amazing thing about so I've written 2 registered reports so far. And one amazing thing about the peer review process is that it felt really different than the other peer reviews I've done. Most of the peer review projects most of my experiences with peer review as an author is submitting it and then having the authors come back, the reviewers come back and say something like, well, yeah, it was mostly well done, but this was a mistake in the methods, or I don't think that this result is very interesting. And you're sort of in the position of having to sell the work. And if they identify a genuine flaw, the authors have the incentive in the response to reviewers to arguing that it's not really a flaw. That's a bit of a conflict of interest in terms of expressing the research in the most honest and transparent way. In contrast, in a registered report, like in the first one that I did, for example, one of the reviewers came back and said, there seems to be a confound between these experimental conditions. Like there's another difference between condition A and condition B that isn't the thing that's being studied here. And I looked at that and I thought, absolutely, that's true. And traditionally, then I would need to have to argue, okay, no, see, it's not a problem for reasons A, B, C. But in this case, because the study hadn't been run yet, I could write that reviewer back and say, thank you very much, that's a great suggestion. We're gonna make these changes to the method. It was like having a lab group, but informal peer review, and it was very friendly. Like it was like the reviewers and I were on the same side, looking at the work and trying to improve it as much as possible, rather than them being a gatekeeper. And that was a powerful experience, and so much more positive than it normally feels. Similarly, the experience of the analysis was much more positive. I alluded to this before. Like when you're about to hit enter on that final critical test, and you don't know whether it's going to be significant or not. If the outcome of that is going to change whether your paper is publishable and whether people will listen to you and whether you're going to get a job and all that pressure, that's very painful. But in the registered report, at that point, the paper's already accepted. You hit return and you get to think as a scientist, oh, is this true? Did we find evidence of this, based on how our methods were set up? And boy, that is a lot less pressure and more why we all got into this job. Okay, so here are the 2 registered reports. One is, I'll show it to you later. It's about observability on prosociality with a pro-environmental behavior task. And the second one, which I won't talk about today, is testing the difference between tables and text for presenting different kinds of risk communications on harms and benefits, and asking which one is better comprehended, helping people to make informed decisions. And it turns out to be numbers in tables are easier to read than numbers in paragraphs, at least with those methods. So where can you send registered reports? Check that link in the lower right. There's a couple hundred journals now. Not that many in environmental psychology, but maybe if we get together and send a petition to Journal of Environmental Psychology or something, and I would be happy to organize that sort of effort, then we can get more. So 219 journals across lots of fields. I just checked and it was about 300 fully completed registered reports have been published. They're taken off. So now is the time. I think we can comfortably say that these are now mainstream. When I was hearing about this work first in 2014, it was still pretty edgy. People weren't sure, why would you do this? Is it weird? It's now normal and it's increasingly recognized as a gold badge of high quality work. They're also cited well compared to non-registered reports. Okay. So I'm telling you about all these cool methods, but how are they playing out? I can show you a couple papers that have used existing free data and hopefully that'll spur us all to think creatively about how we can use the mountain of data that's out there. Kim and Eom is in Singapore as a faculty member now, and he and I trained in the same lab. And he has this paper in Psych Science that I really like. It's about the link between, beliefs about the environment and support for environmental action. We can think of this kind of like the belief-behavior gap that we know so well, or the attitude-behavior gap in environmental action. And he was interested, and he and the team were interested in looking at whether that link differs by country. So the bulk of the paper, it focuses on this result, where they show that the correlation between environmental concern and support for environmental action on the y-axis differs a lot by country. And that's just low to high. You can see that there are differences between countries. And I'm sorry if my face is blocking this, but in the very upper right, way away from the trend line, is the United States. And most of our environmental psych data is from the United States, which suggests that we're missing something about how we're modeling where pro-environmental intentions, support, and behavior come from if the US is an extreme outlier. And then he shows that maybe it tracks this cultural difference, individualism. But the point is, he could not have collected data from all these countries and drawn this really cool plot. The way he did it was using free existing data. And then they added a second study, I think possibly being asked by the reviewers, a smaller lab study manipulating some of these factors. Or was it a cross-cultural study between the US and Japan? I can't recall. Anyway, a small study with feasible collection, and then this large free data. Another project, this one I was involved in by Ante Busic-Sontic, who trained as an economist. We met at Cambridge. He contacted me because I'd done some work about personality and pro-environmental behavior, and we were interested in different kinds of personality and risk concern on a large-scale data set about solar panel installation, because he had done some work about solar panels in the UK as well. So we built this model where personality traits might predict risk preferences and might predict environmental concern, and then all three might drive green investment, so investment in solar panels. And what we found was no personality results, not in Germany anyway. And I mention this for two reasons. The first is that the no results are no problem for publishing a high quality paper with decent methods. And we sent this one to Collaborative Psychology, where it came out. There was no follow-up study in this case. And we used the German the German social household data, which is freely available. So I want to talk a little bit now about the Psychological Science Accelerator. And I borrowed some slides from Patrick here. The accelerator is a very exciting opportunity that I don't think environmental psychologists are using enough. So this started in part because of Chris Jardier, who said it's time to start building a CERN for psychological science. He observed that in physics, they are starting to produce, huge collaborative projects with much better estimates. Like, that's to say their measurements are way higher quality and they have 1,000 authors or something. And he thought maybe some of our reproducibility and replicability problems in psychology can be addressed by larger scale collaboration. And nowadays, just a couple of years later, there are hundreds of researchers all over the world, and it's really impressive to see all the work that goes into sharing studies and materials and making them run across all these different sites for the highest quality inferences. The core principles of the accelerator are diversity and inclusion, not just in the membership, but also in the selection of research questions and how they're carried out. Decentralization, there's not a leader that determines what happens. It's very flat hierarchy, democratically run. The decisions about the elections and transparency around how decisions are made and sharing materials is all over strongly towards principle of transparency. A strong commitment to the best methods wherever possible, and an openness to feedback and iteration. And I think these principles are part of why the members have felt really welcome. There's no old boys club here. One of the parts of the accelerator that I personally find most impressive is how they run projects. So they take applications, which any of you could submit at any time. You could get some environmental psychology work in there. And those applications are reviewed by people within the accelerator. And then a set of studies are selected for a certain year. So in 2021, they're going to run some studies. What should they be? And then those studies, once they're selected as being important, then they're run across lots of different sites in a bunch of different languages. And this is just a screenshot of only the languages from B to H, which is just stunning to me that you can get such high quality, multi-site, collaborative data in a bunch of languages, with these kinds of shared resources. Of course, it means that as a lab, you agree that sometimes you might help run a study locally too. Like you might use your access to participants or your tools, your knowledge to support another research project, which you would then be a collaborator or co-author on. So this, if you want to learn more about it, you can read this paper called The Psychological Science Accelerator, led by Hannah here. It's come out in 2018, but it already has over 100 citations. There's a lot of attention to this work. And if you look carefully, you'll see my name in there somewhere, although I didn't make a big contribution to this. Helped to edit the paper a bit. There are some issues with this large collaborative model, and you can see one of them in the on the last slide. It's kind of confusing how to do authorship, because the traditional model for a paper assumes that this small group of people are highly involved, but you can also have a large group of people that are involved at very different levels. Should they all be authors and collect citations? Well, it's a bit controversial, and that's a current debate. Another issue with using the accelerator is you would have less control over the process. Like if you agree on a certain set of methods, or it goes through internal review there and people decide, well, let's run it this way. It's not the same as running a study in your own lab, but you'll get a lot more data and a lot higher quality. Some of the benefits are that the data collected is less weird. Weird meaning Western, educated, industrialized, rich, and democratic samples, but not just those groups. Also, really any sample that's not representative to the groups that you're trying to generalize to. So that can depend on the research question and the sample you collected and whatever inferences you're trying to state. Benefits are you don't have to be at a big research school with a lot of money to do big science. And I can't stress more the exposure to lots of great, exciting and excited collaborators who are doing cool work and can teach you new things. I'm learning a lot. Okay, I want to swing now in the talk just to show you one final thing to bring you around to how I ended up in a registered report in some of my own work. So this is a broad model of one of my research lines, which is about environmental issues. You can see that we're trying to predict environmental behavior from a couple different things, individual differences like personality and attitudes, but also contextual variables like social visibility. And that's what I want to talk about today. Social visibility is whether someone else can see you doing a behavior. So, here's someone in a park, and he's drunk a bottle of water in a plastic container, and he is now making a decision whether to throw it in the trash or in the recycling. And you can imagine that the recycling might be much farther away, or he's not sure whether to do it. And the key research question is whether that decision and behavior will change as a function of whether other people are around and watching. And they could be seeing it, or they could be hearing about it online, or any kind of awareness that other people have of your decision. We have a motivation, a fundamental motivation to feel good about ourselves and our groups. That from my social identity theory. And it's clear that our behaviors signal our identity and reputation to others. And that's why we select the clothing we do. That's why we speak the way that we do. This extends to pro-environmental behaviors as well. That's the argument I've been trying to make for a few years now, is that we can look and see when it is that these social identities lead to certain kinds of increases or decreases in pro-environmental behavior, either because of internal processes like identity consistency, doing what makes sense to us personally about who we are, but also about identity signaling between people, about demonstrating a certain kind of person or avoiding demonstrating a certain kind of person. And in the upper right here, we have a reusable grocery bag. Lekker means tasty in Dutch. And other people can see whether you bring reusable bags to the grocery. And in the lower right, we have conserving water. And it's a little bit harder to see how long our colleagues or friends let the water run when they're brushing their teeth, or whether they select certain kinds of cycles on their washing machine that use much less water. It's harder to know that. So we can't observe it as well. Now, environmentalist identity is me trying to find a single individual difference that predicts the very most variance in pro-environmental behavior. And it seems to outperform things like political ideology, gender, and other factors of great interest, and enjoying the rank of things that predict pretty well, like environmental attitudes. So on the far left here, we have people that don't think of themselves as environmentalists. They're not necessarily anti-environment, although they could be. They might also just be, no, that's not my group. And then on the right, we have people that see themselves and want to be seen as environmentalists. And so this work came out of a theoretical tradition based on the idea that maybe being watched leads to a preference for green products. This early work was hypothetical decisions and using vignette priming, so not the strongest methods, but very well-cited paper. And we could call that effect green to be seen. And then on the other side, there seemed to be some work I was observing which suggested that people would also avoid pro-environmental behaviors in certain cases. For example, in the US, political conservatives rejected an efficient light bulb when it came with a sticker that said, protect the environment. But they didn't reject the light bulb when it came without that sticker. So it wasn't about the light bulb per se. It was something about what this sticker implies about their memberships. Again, that could be identity consistency or identity signaling, or both. And that kind of effect, let's call it gray to keep away, to avoid being seen as an environmentalist. So one of the insights of earlier work that I was doing on this was to observe that this is the same effect. This is just an identity-based effect. And so the green to be seen and the gray to keep away are just the different ends of the same spectrum. So let's see here, this is the 2018 paper, which we used a multi-level model where we asked people about how visible different behaviors were and how much they perform those behaviors. And then we accounted for a bunch of covariates. And what you can see is that, let's see, how should I explain this? Okay, on the y-axis is how often they did a pro-environmental behavior, where higher is more behavior. And then on the x-axis is how much they thought of themselves as an environmentalist. So you can see that, first off, more environmentalist, more behavior, regardless of the behavior. That makes sense. Both lines trend upwards. But they don't trend upwards the same. There's a difference in slope here. In particular, the behaviors that were rated as most visible by the participants themselves, modeled here within the participant, were engaged in less often for people who are low in environmental identity. We called that effect gray to keep away. We saw the effect at the other end of the scale in different samples. Okay, as an example of this, I came across a campaign a couple years ago, which I found very interesting, run by the World Wildlife Fund. They were trying to reduce rhino horn purchase in Vietnam, and their target was wealthy urban men. And they figured, maybe we shouldn't do a traditional environmental save the earth kind of message, because these businessmen are not that interested in that group. In fact, they might actively resist it. So the WWF made a weird decision, unusual, and that was they won't brand any of the advertisements they put out with their corporate logo or their typical messaging. In fact, they just decided, let's do the most effective thing. And they developed a campaign called Chi, and they promoted a vision of how to be a successful, happy businessman, but without using rhino horn. And so, for example, one of the quotes here is, "Success and good fortune come from within." And it's difficult, to run controlled experiments across whole countries, but there was a decrease in rhino horn use after this campaign, suggesting that it was effective. So the key signaling finding from this line of work is that individuals may signal social identities with pro-environmental behavior. And because of that, current campaigns to increase pro-environmental behavior may backfire in people that don't want to see themselves as environmentalists. So looking at these popular labels, for example, we have eco-friendliness, and over on the right, an organic label, which looks like a leaf. I mean, very clever, and it's green, well done. But it's possible that people that would select those products that are interested in the environment, or the benefits of that product, now don't select it because it signals the wrong identity, because they don't want to be a hippie, earth-loving consumer. It's not totally clear how far this effect generalizes. Most of the data was collected in the US, and that's an open question. The work I just showed you use a 21-item pro-environmental behavior scale. So this is self-report. And the scale has a bunch of different components: transportation, diet, education. So instead of looking at what behaviors have the largest carbon footprint or the largest effect on water quality or something like that, we looked at a broad basket of behaviors to try and capture some sort of psychological construct, underlying construct of willingness to do recurring pro-environmental behaviors. But that has a pretty major weakness, which is that we already know that self-reported behaviors aren't that well correlated with objective behaviors. And so we don't really know the true state of what causes people to do pro-environmental behaviors. So because of that, we ran a registered report, me and Florian Lange at KU Leuven, and he developed this objective, repeated pro-environmental measure, which I'm going to show you in a second, and I just think it is so great. I'm so impressed by it. Okay, what this offered, and the reason I proposed the registered report to him, is that it offered a strong experimental test of the visibility hypothesis that I've just explained. This says stage 1 accepted, but it is published now and fully available 2020. Okay, so his paradigm says you have to make a series of repeated decisions. You can spend 10 seconds waiting for the next screen by selecting car, or you can select bike and spend 40 seconds until you can go on with the study. So the cost to the participant of choosing bike is they have to wait longer in the study, and the whole study will take them longer. But they're told that if they select the car, the fast option, that lights will turn on, physical lights right next to them, and that will waste energy and produce carbon dioxide into the atmosphere. So it's a type of pollution. Then they make a series of choices. For example, if they choose bike, then they're shown a screen that shows none of the lights turned on, and in fact, there are physical lights and they haven't been turned on. But if they choose car, then the lights turn on, and it shows them how much CO2 was produced because of that. Here's a picture of the lights turned on in the experimental setup. I really like this because it is actual pollution, and so then it's an objective pro-environmental behavior. And then because it's repeated, you can titrate the waiting time and the amount of lights to get to sort of an individual person's threshold, in the same way that you would want an exam to have 50 questions, not just one question, to better discriminate between low, medium, and high performing students. So in this study, we had an observable and a non-observable condition where either they had someone doing a task right next to them who could see what they were doing and who was told what this study meant, what the lights meant, for example, or they were by themselves. And in the upper right, it's just the name of the paper and that the main test was powered at 90% for an effect of D equals 0.5. I realize that's a fairly large effect. The observer could see the target in the observable condition. The target knows that the observer knows what the lights mean. And we did a series of manipulation checks you can see in the paper. So the visibility manipulation seemed to work. And then here's our participant pool. This largely students, largely young. I'll move on. The choice of bike, so the pro-environmental behavior here, was heavily affected by the waiting time, such that when there were longer waiting times, they selected the bike less. And the number of lights lit up in the direction you'd expect. And between subjects, we do seem to have captured a pro-environmental task, a task that participants felt was environment relevant, because environmental identity correlated with the bike choice positively. However, there was no moderation. Now that moderation test, quite underpowered, as with all two-way interactions you'll see probably. Not all of them, but most of them. And here's the critical test. In the public versus private condition, did people choose bike more in the public case, because this is a student sample in a pro-environmental town with a bunch of people who see themselves as environmentalists? No, in fact, there was no difference. There was also no difference in another measure we collected, which was of financial donation. So how to integrate this? I think there's still wide evidence for pro-environmental behaviors being social signaling. But much of that evidence is self-report. Some of it isn't. Some of it is objective, like car purchasing, sexton and sexton, solar panels, hypothetical lab purchases. So it's not entirely clear. The earlier work that I did suggested yes, and this replication suggested no, but there are differences in the methods between them that could explain the result, in addition to one explanation being that visibility doesn't have that effect and the hypothesis is wrong. In particular, this was only one context, and they were only being observed by one person, and it was in a lab. Maybe they don't care. Whereas in the earlier study, we were asking about visible to all kinds of other valued people, like family members and coworkers. I would say the next step in this line of research would be to consider what behaviors and to visibility to whom, because they probably care more about repeated interactions. That's what we're seeing from the sort of social dilemma literature in economics than one-off interactions in the lab. But the study that we ran was expensive. A lot of work was put up front to make it powerful, and we were able to submit it as a registered report, which meant that it was going to be published regardless of the results. So for me, a total success. I mentioned the accelerator earlier, and I meant to put this slide earlier, and you can get involved in various ways. You can join, it's free. You can just say, yes, I want to be part of the accelerator, and then you're in, that's it. You can help collect data, or if you don't have resources for that, you can help review studies or give input or serve in a different way. And they also have a Patreon, so check them out. And this is my last slide. This isn't relevant to what we've been talking about, but I just want to mention this in my talks, which is we have a paper out in Nature last year, which suggests that in a huge sample of 80,000 rows in the geosciences, women are given fewer opportunities to talk. Members of minority ethnic and racial groups were given fewer opportunities to talk relative to members of dominant ethnic or racial groups. And the combination was particularly bad, so that women from minorities in particular were not invited as often. And this is scaled to their proportion in the population. So it's not just that there are fewer of them, proportionately, they're also given fewer opportunities. And I think we can all keep that in mind and make an effort to invite underrepresented groups for speaking opportunities. Thank you very much to my students and collaborators who were instrumental in all of this work. I welcome your questions or feedback on the talk and ways I can improve this, or whatever comments you want, to my email there. And I look forward to the questions and answers now. So thank you very much.
That was great, Cameron. So I think you've answered a couple of questions, it looks like.
Yeah, there were a few in the Q&A that I've typed out, but to now take any questions live as well. If there are any other links, I just bombarded everyone with links, but if there are any other links that people want, please just let me know by chat or in the Q&A. Ezra, how have people been asking questions so far in the earlier talks? Is it all text-based?
Mm-hmm.
Yeah, great.
So Nate just posted in response to one of your questions, and I wonder if you want to take that up, saying that he hasn't personally done a registered report, but a colleague had a negative experience, feeling that the reviewer wanted to take charge of the project and change it to a different question that they were curious about. And this is something that I think many of us have experience with in the traditional reviews that we get, which is basically somebody says, yeah, your project's fine, but the real problem is that you didn't do what I wanted you to do.
Yeah.
I wonder how you and others kind of engage with that issue, where it's actually, they could actually ask you to do something different.
That's interesting. I think that's a particular risk with this format. That's one of the few things that, I mean, we get the same questions over and over again, but this one, actually, I could see that registered reports could make that worse because there's more flexibility in your design at this stage. I haven't had that experience, but it sounds real. I mean, I think in this case, one would hope that the editors would protect you from an overly aggressive change. And if they don't, you can take your registered report to a different journal. I mean, it doesn't protect you from a perfect review process. But your option is always to just withdraw, treat your time-stamped pre-registration, and then do your project more traditionally and submit it later and say, well, look, we did settle the confirmatory hypotheses in advance, even though it's not a registered report. Basically, you have lost nothing because you did all the work up front to settle your design, to establish your measurement technique, to do all the whatever. And then if you want to write it up in a traditional way, that work isn't lost. It just means you did it in advance.
Yeah, I mean, as I was listening to you talk about registered reports in the process some more, I mean, I could see advantages for certain types of work in particular, like longitudinal work or work that's going to take a time to collect data, whether it's a single data point or it's multiple data points that you've baked in. You've avoided some of the publication bias issue by, people have made it through that first stage of review, and so maybe they're more open to doing work that will take longer. On the other hand, though, you don't get the full credit for whatever the work is until everything's been done. And I wonder if that's an issue, especially for early career researchers. I could see it going again ways.
So I think the timing is a concern. You basically are going to line yourself up for a longer process, but there's lots of traditional work that gets dragged out ages and ages. I mean, I just published something that was 6 years and it's just, I mean, my feelings about it So it's like not doing a registered report is no guarantee that you'll have an easy publication process either. I don't know. There's one question. Let's pivot to that from Laura, who suggests that registered reports might be great for well-controlled lab studies, but perhaps not as good for field studies or less controllable methods. I think to clarify here, the registered reports are a really good format for confirmatory hypothesis testing, where you can sufficiently control that you have sufficient power to test the assertion that you're making. Lots of research doesn't fit into that. And so there's work, that's more descriptive or exploratory. There's work that's more qualitative. Maybe these are not as good a fit for the registered report format. There are some groups doing those right now, exploring, how do you pre-register a qualitative study? And there's some cool papers on that. But this isn't a one size fits all. I think what it does is, and then there was another question about this, I think it further illuminates to us the context in which we took descriptive, loose work and then packaged it as confirmatory. And it shows us further and further, wait, what is a real confirmatory hypothesis test with sufficient power, and what is everything else? And that everything else is still super worthwhile. And I would love to continue to see lots of papers. And I review descriptive work very positively, to be honest, when I see it. I'm really happy to see it. But I'm becoming sensitive to this difference of exploratory, loose work that's being packaged as confirmatory.
I wonder, just with our last couple minutes, unless another question comes in, you told us a little bit about your own kind of history and trajectory of moving in this direction of kind of open science and more reproducible science. But the subtext there is that you didn't get training in this during your own graduate training.
Yeah.
This is something you had to kind of go seek out on your own over the past, whatever, half decade that you've now been moving in this direction.
Yeah.
And I wonder if you've got some advice or recommendations, especially for our early career folks who might be in labs that are run by, let's politely call them old school researchers in environmental or other psychological fields, who are not going to get this training from their current advisors and even their entire programs.
Yeah, well, that is a good characterization of the training I experienced. I didn't get mentorship in these kinds of techniques that we've been talking about today, and did have to discover them on my own, which was part of the reason that connecting with these groups, like the Accelerator, like the Improving Psychological Science group, and all their meetings are, virtual now. They're very accessible, as well as Twitter, which for me has been a really great way to connect with people, was the way that I felt the social connectedness and lots of people are doing this, and how do you go about this? And so for me, connecting with people that are also curious about it was the main route to success. And I really am delighted by this whole thing, because I would characterize, if you go back 10 years, during my PhD training, I would characterize what I thought my highest goal was to produce these like 7 study JPSP papers that are just super, all the p-values right under 0.05 and everything's brilliant. And I never produced that kind of work with the methods that I was using. I think we could infer that some of those papers are maybe not so reliable. And so for me, it was a great relief and a feeling of expansion and ease to find a community that was more focused on methods and less focused on those outcomes.
Great.
The shared data set. Yes, I will share that again.
Great. And of course, like all of our other talks in the webinar series, this one will be posted to the Division 34 YouTube channel. You just search for APA Division 34 anytime. And I want to thank Cameron again for joining us today. And it was really great to hear your perspective. And I think you've got, as I said earlier, a lot to contribute to this community. So I'm glad that you're making yourself and your expertise available.
That's really kind. Thank you very much. I'm delighted to speak with everyone. And I consider this an open process. I don't have any answers. I just like some of these methods. They're fun for me and my students, and I hope you find them so too. Please feel free to look me up by email or Twitter for any questions. Thank you, everyone.
Great. Thanks a lot, Cameron. Have a good day, everybody. And hopefully we'll see you back in actually just a few months with our last talk for 2020, which will be with Neil Lewis Jr. from Cornell University. Bye all.